In this video, we will do some U-substitution examples that involve powers of some variable, like x. So in this first example, we have this integral of x to the third, parentheses 2 plus 5x to the fourth, parentheses to the 10th power dx. So I want to begin by giving a tip. That can help us identify what to let u be equal to. So the tip is, if we see a function and its derivative in the integral, but maybe the derivative will be there up to a constant multiple. So maybe it'll be off by a multiple of 3 or a multiple of 1/5 up to a constant multiple. Then the tip is, try letting u be equal to this function that we saw in the first place. We're going to try letting u be equal to that function. Okay, let me highlight this. So in this question, I do see a function and its derivative in here up to a constant multiple. Okay, and so the function that I see is this thing over here. If I let u be that 2 plus 5x to the fourth, its derivative, du dx, would be 20x to the third. And I do see that in my integral, just without the 20. I see an x to the third in here. And that's the type of thing that this tip is talking about. Okay, so recall from the last video, what do we do with this? Well, we rearrange this. We treat the du dx as a fraction. And I move the dx over to get du equals 20x to the third dx. Okay, and in this video, I want to talk about two ways that we can handle this du and dx term. So method one for handling that term is to isolate dx. And that's what we did in the last video as well. So if we isolate the dx, what would happen is we would have gotten, I would divide by 20x to the third, du over 20x to the third equals dx. And now we're ready to substitute in. So our integral would end up being the integral, we'd have the x to the third in the front. And then when I plug in u, we'd have u to the 10th power. And when I plug in for dx, dx is is du over 20x to the third. Okay, so now this is really nice because the x to the thirds cancel perfectly. Okay, so I end up with, let me pull the 20 out to the front. So I get 1 over 20 integral of u to the 10th du. And the reason why that perfect cancellation happened was because the du had this x to the third term. So when I isolated dx, the x to the third term came to the denominator, and that's what led to that cancellation. All right, so now let's do this antiderivative. So doing it, we end up with that 1 over 20th times reverse power rule. We get u to the 11 over 11 plus c. The last thing I got to do is plug in for the u. So if we do that, we'll get, what was u again? It was 2 plus 5x to the fourth. 2 plus 5x to the fourth, that whole thing to the 11th power, over 20 times 11 is 220, and then plus c, and that is our antiderivative. Okay, so there's one other way we could handle the du. So method 2 for handling that du is, instead of isolating dx, we could try to isolate the terms in our integral. So what do I mean by that? If I look at du, it's 20x to the third dx. And if I look at the integral has x to the third dx. So I'm going to isolate x to the third dx. So doing that, we would get du over 20, because I don't want the 20 there. That would be equal to x to the third dx. And now we are going to substitute. And when we substitute, we'd end up getting our integral. So when I plug in the u, I'd get u to the 10th. But then all of the other stuff, So the x to the third and the dx, well, that's this. That's just du over 20. So we have this times, let's put it in black, times du over 20. Okay, and from here, this is the integral of 1 over 20 times the integral of u to the 10th du, and that's the same thing as I had before. So from here, the rest is the same. I'll just write dot, 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 rest is the same. Okay, so we have these two ways. They're very closely related, just slightly different, for handling the du term. All right, let's do another example. So in example 2, we have the integral of 2 plus 5x to the 4th divided by x to the 3rd. So I'm going to try this in two ways. So attempt 1. In attempt 1, I'm going to let u be 2 plus 5x to the 4th. Because I might look at that and say, wait, I see the derivative of this in my integral, off by a constant multiple, because I see this x to the 3rd term. So this time, instead of writing du dx and then moving the dx over, I'm going to jump straight to the step where I write the du. So I'm going to take the derivative and already move the dx over. So doing that, we'd have du, I just think of that as the derivative. And over here, when I do the derivative, I'll get 20x to the 3rd, but I'll already have moved the dx over, and I'm going to write that here. Okay, so let's do it the first way, where I isolate the dx. So that'll give me du over 20x to the 3rd equals dx. And now let's try to substitute in. So if we take our integral and use this, we get integral, the numerator is u. On the bottom, I still have that x to the 3rd. And when I plug in for the dx, we'll get du over 20x to the 3rd. But this time I don't have that nice cancellation happening. Instead, if I simplify, we'll get u over 20x to the 6th, and let me just put the du at the end. So if we do a u substitution and we substitute in, but we still have the old variable lingering like we do here, we could try to use our u substitution again. So we could use u equals 2 plus 5x to the 4th and try to rearrange this so I can isolate x and plug in for the remaining x's. So I'm going to try to use this again. So if we do that, let me isolate x. I'll get u minus 2 equals 5x to the 4th. And then dividing by 5, we get u minus 2 over 5 equals x to the 4th. And then if we fourth root both sides, we would get u minus 2 over 5. Fourth rooted, but when I even root both sides, I got to put a plus or minus, and that's going to be equal to x. So now let's take that and let's plug it in for this x. Okay, so if we do that, we end up with the integral. So this integral now becomes the integral of u over 20 times this plus or minus fourth root of u minus 2 over 5, that whole thing to the 6th power, du. So I have my integral completely in terms of u. It's just worse than I started with. It's not easier than the one that I started with. And that kind of defeats the purpose of u substitution, because it's supposed to make my antiderivatives easier. So the takeaway from this is that we can get most u subs that we try to transform our integral in terms of just u, like what happened here, but not every u sub is helpful. So before we do this antiderivative correctly, I want to return to this issue of, well, when we let u be this thing, du had an x to the 3rd in it, and my integral has an x to the 3rd in it. So how come it didn't work like the previous example worked? Well, the reason for that is this x to the 3rd that's in my integral is on the denominator. So it's kind of like we have 1 over x to the 3rd in our integral. And that's not what my du is. My du has x to the third on the numerator. And my integral has the x to the third on the denominator. That's why it didn't work. All right, so now let's try this a different way. I'm going to call this attempt 2. So I could have done this integral more simply by noticing I could simplify this first. This is going to be 2 over x to the third dx. All right, so now let's try this a different way. I'm going to call this attempt 2. So we might notice that we can simplify this function, and I can split it up into 2 fractions. So I get the integral of 2 over x to the third plus 5x to the fourth over x to the third dx. And now I can simplify this. And for the 2 over x to the third, I can rewrite that as 2x to the negative 3. And the next term becomes 5x. And now this is something that I know how to take the antiderivative of. I'm just going to equals ... And it is easy from here. Easy from here. So the takeaway is that not every integral is going to require U-sub. Some antiderivatives we can handle just using our previous methods, like basic antiderivative rules, or first trying to simplify our function so that I can take the antiderivative. So we want to be mindful of that. Okay, next example. We have the integral of 1 over 25t plus 3. So for this one, I want to give you a couple of minutes to try it. So pause the video for 3 minutes to try this one on your own. Pause it in 4, 3, 2, 1. Pause it and try it for about 3 minutes. All right, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. Let's talk about it. So for this one, I'm going to let u be the whole denominator, 25t plus 3. So when I write the derivative, instead of writing du dt, I'm just going to write du and then move the dt over to the other side already. So the derivative on the right is 25. And now I've got to write the dt because I've moved it over. That's going to be really important when we do these U-sub questions, to not forget this dt or the dx or whatever this is on the right-hand side. Without it, it's technically not correct. Okay, and now let's isolate the dt. So I'll get du over 25 equals dt. And by the way, I know this U-substitution is going to be helpful because its derivative is 25, and I see that in my integral just off by a constant multiple. Because in the numerator, I see the 1, and that's 25 just off by a multiple, off by 1 over 25. Okay, so when I plug in, we get integral of 1 over, the bottom is u, and then dt is du over 25. So I can pull the 25 out in front to get 1 over 25 times the integral of, this becomes du over u. But du over u, maybe it would have been simpler to just keep this. This is the same as 1 over u du. And we know how to do the antiderivative of that. So I will get 1 over 25. 1 over 25. Antiderivative of 1 over u is ln absolute value of u. Got to put the plus c, because this is an indefinite integral. And now I got to sub back in for what u was. So I get 1 over 25 ln absolute value of 25t plus 3, and then plus that c. And that's our answer. Okay, let's do example 4. This one looks very similar. It's just the bottom has 25t squared rather than 25t, like the previous one. So the first thing that I want to mention is something to be careful about. Just because the last one had an ln doesn't necessarily mean that this one will. In fact, this is not going to be just ln of absolute value of like the whole denominator, 25t squared plus 3. So let's check that. This is the case since if I were to take the derivative of this thing, if I were to take d dt of the ln of absolute value of 25t squared plus 3 absolute value plus c, well, we know the derivative of ln of stuff, even when there's an absolute value, is just, this is going to involve chain rule. I'll have 1 over the stuff, 25t squared plus 3 times the derivative of the stuff, which is going to be 50t. Okay, 50t, and the derivative of the plus c is 0. But that's not the function that I started with, because it doesn't have a 50t in the numerator. Okay, so because of that, this doesn't work. So it might be super tempting to like pattern recognize a little bit and say, wait, last one had this ln, and will this one have an ln? But it turns out that's not the case. So conceptually, the reason why is if we try to let it be the ln of that whole denominator, when we do the chain rule on this one, the derivative of the inside will involve a t. And that doesn't show up in my original integral. There was no t there. Whereas in the last one, if we did ln of the whole inside, when we do chain rule on this, the derivative of the inside will be 25, which is just a constant. And that's easy to sort of cancel out by putting this 1/25 in front. Okay, so how are we going to handle this? How are we going to handle number 4? So the idea I'm going to use is that this looks like the integral of 1/t squared plus 1, which we know this is arctan. This is arctan of t plus c. So what I'm going to try to do is make my integral look more like that. So I would need to have this plus 1 here, and to get that, I'm going to first factor a 3. So if we factor a 3 from our integral, we will get the integral of 1/3 factored out, and we'll get 25t squared. I got to divide by 3, and then I'll have a plus 1 dt. And now let's move the 3 out, so I'll get a 1/3 in front, integral of 1/+1 here. And I'm going to rewrite this whole thing, this first term, as something squared. And inside, I would have to have 5t over square root of 3. Oh, okay, and I still have the dt at the end. Now, we're going to be ready for a u-sub. I'm going to let u be the thing that's being squared here. This is 5t over root 3. If I take the derivative, I'll get du equals, the derivative of this is 5 over root 3. Remember, I got to write the dt. Okay, so now, if we isolate dt, I would get root 3 over 5 du equals dt. Now let's sub in. So I got 1/3 integral of 1/, I'm going to now have u squared plus 1. And then plugging in for the dt is root 3 over 5 du. Okay, so root 3 over 5 is a constant. I'll move that to the front, and I'll get root 3 over 15. And now I know how to do the antiderivative of 1/u squared plus 1. That's going to be arctan. So I get arctan of u plus c. Then I got to plug back in for the u. So I get root 3 over 15 times arctan. My u is 5t over root 3. And then we have the plus c. And that is our answer.